more useful if you take the lid off. We're going to pour about 20 or 30 ml of methylated spirits into here. Now just a word about methylated spirits, ladies and gentlemen. Methylated spirits is one of the more dangerous things you'll find in your home. Do not stuff around with this stuff. It's highly combustible. In fact, it's explosively combustible. But when it burns with a very, very dim flame, as you're about to see. If I didn't have the lights off, you wouldn't see this burning. And if you catch fire with methylated spirits, people often can't tell that you're on fire, which is a problem, generally speaking. So do not mess around with metho in the home is the take-home lesson for today. All right, we're going to tip the excess out of that. So what I've done is I have swirled methylated spirits down around the outside of that. Is there air inside this jar? Yeah. What's the air contain?
Oxygen.
Oxygen. Okay, so all that's required is a little spark. Let's go. Actually, I might even. I was given tongs, so I wouldn't burn my knuckles as I did this. So let's have a go. You ready? 3, 2, 1. Burnt knuckles it is. Right. 3, 2, 1.
Oh, that's 6.
Again.
All right, let's try it again. Let's try it again. Just make sure that there's no flame happening here. Have a feel of the container, guys. Yeah, as you would expect, flame cone. What kind of reaction is it?
Combustion.
It's highly exothermic. The reason you can see flame is because the air has gotten so hot it starts to glow. That's what flame actually is. Now, let's go again and let's see what happens. So, we've got all the same ingredients. We've got our methylated spirits. And swirl. Technical term. The only thing different is that that's got a dead match floating inside it. Now, we tip the methyl out. Wasn't it interesting how it kind of goes and then there was it sort of puffed a little bit? On and off and on and off and on and off and on and off. Looks brilliant in slow motion. All right, predictions. Same thing? Who agrees? Okay, let's have a look. We can do it on slow mo on the thing. Ready? 3, 2, 1. It's only burning in the neck. It is puffing a little bit in the neck. And it's actually still burning. I don't know if you can see just under the spout of it. Didn't work. Why not?
Because of the match?
No, nothing to do with the match. I actually got the match inside this time. Why?
There's no air inside.
What do you mean there's no air inside?
No oxygen.
Ah! It got used up in the first reaction. So what is in there now? Carbon dioxide. The exhaust gas of the first reaction, carbon dioxide, is what this is now full of. So when I do the same reaction again, all that fuel is still sitting in there unburned. It hasn't reacted because there was no oxygen there for it to react. So in order for us to get that to go again, we've got to rinse all the carbon dioxide out. So, well, carbon dioxide is a heavy gas. I could try doing that. I don't know if that'll work or not. But it is heavy, so it should fall. But the problem is it's also hot. So maybe it's going to be a little bit buoyant and stay up in there. Generally speaking, we just rinse the whole thing out with water and tip it out and let it dry, and that's enough for it to happen. Okay, that'll do.